So we continue further. So now if you take what you mean by sampling, so if you take in statistics, so it's already been done. So now, so whenever you are doing the sampling, so you are going to resample again and again to revise that particular precise to get the precise data. After multiple sampling will done, so you are going to get the defined data. So now, whatever the uncertainty you are going to create by doing that particular sampling process, as that particular name is referred as what sampling distribution. So you are going to distribute that particular sample. So we are told that, for example, if you take the email, so first I'm going to filter out using the date. After filtering out with respect to the date, I am going to filter out with respect to the number of sentence. Okay, so next number of sentence which are being used. After filtering out with respect to number of sentences, I am going to filter out with respect to the word and number of verb. After going with that particular verb, so I'm going to arrive at some analysis. Okay, some analysis you are going to make. So these are the, but this is your sample you're going to take with respect to some date, and you're going to sample it with respect to some sentence. Okay, and you are going to make the sample with respect to the word verb. So after doing all these things, what will happen? We are going to arrive at some conclusion. So now, so whatever the answer it, so due to this work, what I have been done, so this particular sampling process, what I have been used, so that will be creating some uncertainty. So that uncertainty which you are going to have, that term is called as what? Sampling distribution. Okay. So now when you take the data, so if you take the big data, already we know that. So in the big data, what will happen? So what there are different kinds of data which you are going to have. So whenever you are going to have the data scientist, so the what should be the role of data scientist? A strong data scientist need to be versatile and comfortable with any type of data he is dealing with. Okay. So a data scientist needs to be versatile and is ready to deal with any type of data. So dealing with any type of data or supporting to any type of data or any variety of data which is going to have. So here, if you go with the different types of data which is available, so they're going to have differentiated. So depending upon the um, different types of data which you are going to use. So if you are going with the make use of the traditional data, which is nothing but your numerical data is there, categorical data is there, or it may be a binary data which you are going to have. So it is some of the data with respect to traditionally we are going to use with respect to the numbers. So if you take with respect to text, so text you are going to make in mail, so text you are going to make it in emails, and you are going to make this in tweets, and according to the book they are going to tell it in New York Times article, but according to the text where you are going to make when you are writing the articles. Okay, so when you are writing articles inside your when writing articles also, so then so this the text will be used in these places. Okay, this particular data is used in. Now whenever you are going to create some records, so records the other kind of data which you are going to have, it will be the data which is stored in the records. So the records which you are going to have is what? The user level data, so which is records. So like your results is one record which you're going to have where it is going to record the results of an individual student. So it is user level data which you're going to have. So whenever you are going to get the result of that particular thing, or if the email, so that means whatever the event is going to happen, it is going to be time stamped event data. So that time stamped event data will be there. So then whatever the log files you are going to have, so log files you are going to have, so JSON formatted log files you are going to have it here. So JSON formatted. So already we know that. What do you mean by JSON? JSON stands for JavaScript object notation. So JSON stands for JavaScript object notation. So that particular notation, that particular data will be stored. Then the another type of data which you are going to use is geo-based location data. So that means geographical location. So it depends upon the geographical location. So based location is going to take. So like in which place is there. So then you are going to get the data from network. So that when you are going to make use of the network here. So next is the census data. So normally this particular data you are going to use it in IoTs. So whatever the sensor or in the climate prediction, you are going to make use of the climate prediction also. You are going to make use of the sensors, and it may be used the sensors you are going to use in when you are going to um, minimize the traffic in the signal, because I have to check for how many vehicles are there in that particular junction. So depending upon that particular density of the vehicles in that junction, how I have to align my traffic so signals. So for that particular thing to be happening, so to analyze that particular data, you require the sensor data. So there in the sensor data, what you have to capture. So sometimes, so you can make use of images also. So the images also, but these are the some set of data which are going to use. So the some set of data which the data scientists are going to be used. So to make to arrive at the conclusion. So what one is traditional, other is text, one is record. So geo-based location data, network, sensor data, and images. So these are four different data, different types of data which the data scientist has to deal with. Okay. So when they are to arrive at some of the conclusion. So next comes what do you mean by big data? So if we take the big data, already we know that. So whatever the conclusion we are going to arrive, or whatever the statistical inference we are going to make, so that is going to be done with respect to the big data. As I told you already, so the data which is growing every day, every minute. So that will be defined by your big data. So if you take the data is such as one petabyte is meaningless because it sounds absolute. Because according to the standards, already we know that whatever the data we are going to have in greater than 1 petabyte, so that particular data is referred as what big data. So already we know this particular thing. So the data which is greater than 1 petabyte is referred as big data. But it's not because according to the textbooks when you are doing, so it is not related term referring to it when the size of the data outstrips the state of the art computational solutions. Okay. So what that particular statement means. For example, if I may have the older system of P3, for P3 data, for P3 systems, if I'm going to give only 1 GB, around 100 MB of data, so this particular system will process slow. This processing is slow. So that is my important. So your P3 systems having low computational facility. So it's going to have low computational facility. So due to this low computational facility, what is going to happen? So it is going to uh, do the computation late, and after doing the computation late, the whatever the result it is going to give you, so that will be not accurate because it has to do all the manipulations, calculations they are going to have, and what is the storage it is going to have. Because if you take the older systems like P3, so P3 if you take, so at that time, so the size of the hard disk which are going to available is around 250 MB or 500 MB. Okay, so now we are going to have the size of the hard disk up to 1 TB, or 5 terabytes is also available in the market. So, but when you are going to have the older systems, the number of size of the data, number of size of the storage which you are going to have is this much, that is 250 MB or 500 MB. So due to this, what will happen? There will be a shortage of memory to store the data. So if you are going to have the shortage of data, shortage of memory, to store that particular data, so I cannot use the data which is required for my analysis. So for that particular thing, what the different people are going to tell is, so it is going to be, it is not the same definition what they are going to give. So if the size of the data outstrips the same current computational ability, which is able to handle it. So that is P3 cannot handle the data of up to GB. Okay. So if it is P4, so P4, even P4 cannot handle the data up to 1 GB. So if you take the I4, I3 or I5 or I7, these are the recent processes which are going to have. So real core we are going to have. So these systems what they are going to have. So they are going to have more computational facility. So the computational facility which you are going to have in these systems are more. So when you are going to have this particular computational facility of more, so it is going to be used more effectively. So more computational facility. So the resources which is going to have. So even if it is going to support up to 16 GB of RAM. So if having this particular data, this particular facility or processing speed of that particular system, so it can handle the big data and it can give you the result. But it is not the same case with the older system. But the older system can handle only the small amount of data. So, but the higher system is going to do the computation for large amount of data also. That is the reason why earlier we have already discussed this, what is the difference between your academia and industry with respect to the data scientist. Why it is necessary to discuss about that one. So whenever you are going to have the outstrip of the current computational solutions, so that it is not going to tolerate big data. Now, what do you mean by big in your big data? So according to the author, which is where textbook has been written, so the big data refers to what? So the data which can't be fit on one machine. Big is when you can't fit that particular which when you can't fit it in one machine. So that is nothing but what? So whatever the data is required for your analysis. Okay. So that particular amount of data you cannot fill it. So not enough to fit the data into the computational system available. So that's why the author is going to specify the big data definition in different terms. So the author is going to tell what, so according to the textbook author is going to tell that. So the big refer in the big data. So the big refers to what? It can, where you can't fit that particular data into the one machine. So that means what? It's not enough to fit the data into the computational systems which is available. Now, if you take with this big data, so what is the big data? So normally big data when you're going to have, so it's basically it's a cultural phenomenon which is going to happen because already we have seen that. So the data which is going to be generated every day. So every day from the day we start with the day we end. That is the day, the time at which we are waking up on that particular day, and the time at which we are going to sleep on that particular day. So this is the sequence of phenomena which is going to happen. So within this particular time bound, so how much data it is going to be generated. So how much data is part of our lives. So what is the precipitated by accelerated advance in technology? So for what purpose we are going to have. So for that one, what the big data is going to do. So they are going to have the characteristics of big data. So already we have seen what is the characteristics of big data. So big data characteristics according to the NIST and ISO, what they are given. So it is going to be ISO. They are going to have 3 V's. But according to the author, is they are going to give it as 4 V's. So 4 V's are what? So one is volume, other is variety, other is velocity, and other is value of that particular data. So we already know that whatever the data you're going to generate, so the data will be generated from the time which you wake up till the time you go to sleep. So there is enormous amount of data is going to generate. That is one of data which is generated every day in your day-to-day life. So so after the having the huge volume of data, so the data which you're going to have is having different variety. That means what? So once you see that particular result, that will be in the text form. So once you see some videos, that will be in the video form. Some data will be there in the image form. So then some will be there in the location form. So these are the number of different varieties of data which you're going to have. And then whenever if you go with the third characteristics of your big data, so the third characteristics tells you the velocity. Okay. So what do you mean by velocity? So the velocity is nothing but what? At what faster rate the data is being generated, because the data, as we are told that the data is generating from the day from day-to-day life. Okay, so when your data is generated from the day-to-day life, at what faster rate that particular data is being generated. So the velocity at it. So velocity refers to what? Speed. So here the velocity refers to speed, the speed at which the data has been generated, and the value of that particular data which has been used. So this is the 4 V's which are going to have. So that is volume, variety, velocity, and value. So now other V's are also changed, like velocity is there, scarcity is there. So even that is not considered as the standard, because someone has to standardize that one. So these are the basic 3 V's which are there. So according to the NIST and ISO standards, so basically 3 V's, but according to the author, what they have given in the book is going to refer as 4 V's. So the 4 V's according to the author is what? So one is volume, other is variety, other is velocity, and other is value. Okay. So now we come across that particular things which is sample. So and sample is nothing but what? It is a subset of the units of size n in order. Okay. So it is subset of the units of size n. So you are going to have size n. So assume that you are going to have 1, 2, 3, 4, 5, 6, around 10 are there. So from this particular 10, you are going to take the subset. So that means only certain numbers you are going to take, like 2, 4, 6, 7, 9. So this is the set which you are going to have. From this particular set, you are going to take the certain subset of the size n. So for what purpose you are going to take this particular subset? You are going to take this particular subset to make the observations, to examine the observations. After doing the observations, what you are going to make? So you are going to draw the conclusions. So you are going to draw the conclusions, or you are going to make the inference about the population. So what the group of people or group of object or group of set which you are going to consider, so is going to tell. So it is going to tell that. So first I want to check that who is going to be topper. So set, if I'm going to have the set who is topper of the class, so first I'm going to take out all the percentage, like It is by 60, some will be 60, 61, 62, some will be 81, 82, 83, so 85, 86, like that and all. So if from this one, I am going to take the subset. So if I take the subset, I will take only the values from 82, 83, 85, and 86. So from this one, I can arrive at the conclusion that, so even if here you can bifurcate, so I will make another subset which is greater than 85. So that is 85 and 86. So now from here, I can get to the inference about the population that these two people, the people who are holding the percentage of 85 and 86 are the toppers. So now when you are going to have that particular, getting that particular subset, so there are different ways you might go about getting the subset of data. So if you want to get this particular subset of data, so this referred was what? Subset of the data. So when you want to get the subset of data, so you have to go with a different mechanism. Okay. So because from the entire population, you have to shrink down depending upon certain attribute. Okay. So here I'm taking the example of your class. So once you take the example of your class to find the topper of the class, first I have to take the list of the class, right? After from the total 6M list, I have to take bifurcate what is the class for class A or for section A or section B. After taking that those names, so I have to bifurcate that who has got more than 70%. So because if it is getting more than 70%, then they are treated as distinction. So now after arriving at the conclusion that these many people have got the distinctions in this particular class, so then I have to find the topper in the particular class. So next I have to sort that one. So sort in the ascending order, who is from top to the bottom. That particular data, I will again check that whether any person is there who is going to have more than 80%. So if any person is there more than 80%, I will create another subset of that one. So when you create the another subset of that one who is going to have more than 85%, so then from that particular set, I'm going to decide that who is going to be topper of that particular class. So when you are going to have to do these particular operations, proper mechanism has to be taken while doing this particular sampling, because the sampling mechanism, when you are doing it, if it is not proper, then it can introduce biases into the data, or some unwanted data may come into the picture. So for example, so biases is there, but what sometimes what will happen, the one person was there not your class may be included in your class by miss. Okay, so because sometimes what will happen, so since you are human being, so it is not we are not going to do the exactly accurately. So due to some of the limitations, what may happen, the other class person who is there as a topper, so may be included in our database. So at that time, what will happen? Again, that particular person will be showing that one as a topper of that particular class. So that is what the simple mechanism, simple analogy, what I am telling. So what are the different mechanism you have to take? Okay. So when you are doing the sampling, since the sampling mechanism can introduce the biases, okay, into the data, and whatever the biases it is going to introduce into that particular data, what it can do to the data, it can distort the data. So that the subset is not the minimi, shrunk down version of the population due to the biasing. Okay. So that's what it is going to have. So if you take the, for example, if you take the consider the sample of the people who have sent the email in the organization, so the maximum people are sending the email for a single person, what can be the inference made? Okay. So that is what one thing we can have here. Okay. So if you take that particular example as an example of sending the email. So in this particular term, so if you take that from that particular sample, so if your maximum people are sending the email to a particular person, so what is the inference you are going to make? Okay, so that you have to get it. So once you have done that one, so what is the in the professional network? If maximum something the information of a certain technology, because now it is a boom in your big data. So now maximum people in the Google search or professional network they will be turning big data. Now whatever the page they have been using differences. So any page if you take, so they will be having the rank for the particular page. Depending upon the rank of that particular page, what will happen? That particular page will be displayed first. Okay, so that's what is going to happen there. So we are going to have the ranking of that particular data, and depending upon that ranking of that particular data, the page will be displayed. So now in retail, people have ordered a particular product frequently. So that is nothing. So if you take with the retail, that is nothing but your Amazon and Flipkart is the best example what you can take. Amazon and Flipkart as the best example what you can take. So you have ordered a particular product frequently. So that is it is going to be recommended. So that is one thing which you are going to have the recommend or samples which you are going to take. So even in the Flipkart, the same thing happen. But in finance, what will happen? The people who are applied the loan application to a particular bank. So this can be taken into consideration here. So depending upon the type of the person who has applied the loan application, and if the repayment is proper, okay, for one thing, and his salary is high, so then what is salary is high, so then we can come to the conclusion that loan can be sanctioned. So loan can be sanctioned. So these are the things which are going to have. So another sample what we can take here is what another sample is how many years is working consistently in a single company. How many years he is working? How many years the person is working? So this is another observation what you can make for arriving is working to arrive at the conclusion. Okay, depending upon these attributes, that is repayment for the previous loans. So this you have to get it for previous loan. So previous loan repayment is proper. So then that is one parameter. So if the person's salary is high, and if that person is working for a longer time in a single organization, then obviously is consistent and be treated. So then the sanction of the loan will be high for that particular person. This is how your analysis will go. So if you take in the retail, what will happen? So if you are frequently ordering product, so it's going to recommend you that so that particular product you are going to use that one in the near future. So that's what it's going to have it here. Okay. So these are the things which are going to have it. So if you take the sampling, so the kind of sampling is also same thing. So if you go on the enterprise solutions such as Adobe, so in Adobe, what will happen? So it is going to handle engineering and computer that causes by too much data. So Adobe, what it would have, so it is one thing, so it is going to paralyze the application. So Adobe already, you know, some of your right, so it's going to paralyze the application. One task will be there. So this particular task is going to be divided into a number of subtasks. Okay, subtask it is going to do. So each individual task is going to provide. So then it is going to merge it at the end. The result was going to be end. So the entire process is going to form. So Adobe is nothing but parallelism. It is going to achieve with respect to each node. Parallelism is achieved in each node. So in Google, if we take the Google website, so what happens? So at the back end, all the sites as to be displayed. So for that one, what will happen? We will be working, the software engineers, data scientists, and statisticians will be do the sampling all the time, because I have to give you the relevant result when you are searching something, right? So who has to work for the turn? Even software engineer has to work, data scientist has to work, and the statistician also work. So take the TV showroom, taking the interest of the customer indicates that what the customer is interested in, what features the customer is looking into. So depending upon that one, that particular product I have to recommend. Depending upon that particular interest, I can tell you that so this particular product or this particular company product is having these facilities. So you may be interested in this particular product TV. So that is what the example for your TV showroom interest TV show in the TV showroom example. Okay, so this is how the decisions and conclusions has to be arrived. So decisions and conclusions has to be arrived here. Okay, so it depends upon the enterprise solutions which are being used. So all this thing will be done in parallelly, because each individual can do not handle the big data. So to handle that particular data, big data, you are going to make use of the Hadoop. So that is the main tool which you are going to have it. So we'll stop here now. So you have the quiz started quiz now. So the last topic for this particular module will be, I'm going to complete it. So that is the data science process. So that will be the important question for your exam.